Right, the knowledge of alloy is out of syllabus in DSE, so that's why I would like to explain it here instead of using the lesson time. So alloy is a homogeneous mixture, or you can say the even mixture of a metal and one or more other substances. Like for example, carbon, and the mixture still has the metallic properties. For example, steel, brass, that means 金黃銅. Bronze, that means 青銅. Right? You know, if we mix metal of different sizes into the structure, then the packing will not be very uniform. So that will make the alloy become poorly electrical conductive and more corrosion resistant. But let's see a diagram. So originally, for the metallic structure, all the metal ions are in the same size. When there is an electric field, the electrons can move freely and smoothly in the circuit to conduct electricity. But if you have mixed two metals or even non-metals in the same structure, then the electrons cannot move very conveniently due to the different sizes of the rod. So that is the case why the electrical conductivity decreases. At the same time, since the electrons are blocked by the metal ions here, so the release of electrons will become less difficult. Okay, more difficult. So that's why the corrosion resistance will be higher. So stainless steel is a very common alloy type of the iron with other metals. It is hard, strong, and more corrosion resistant than iron. It is used for structural uses such as car bodies, bearings, and knives. In whatever regions that the application needs a longer application life, then we will use a more corrosion resistant stainless steel to replace the iron. But we still have some applications that we don't care about the corrosion. For example, the drainage cover, the bridge, the pillars, the road pillars. We can use other cheaper methods to make the rusting slower, or to avoid the rusting. So alloy, to make the alloy, we need to use a very high temperature to melt the metals in order to let them mix well. So that will be quite expensive. There must be some reasons for the scientists to do so. So let's investigate these properties. So for the alloys, it will be stronger and harder than the pure metals. Actually, most applications in our daily life would have mixed some metals in order to reduce the malleability and ductility of the metals. You can imagine if the handle of the door is made of alloy, but if it is made of metals, when you turn the knob then the metals of the knob will change the shape due to the malleability, right? So that will be quite nonsense. So we need to make it stronger by mixing some impurities into it to reduce the malleability and ductility of the metals. So the reduction of the malleability and the ductility is similar to what we have just described here. Originally, the metals can slide down, so without breaking the metallic bonds. You can slide down, and then the electrons can follow. The metallic bonds are still there, so the metals can extend the length and become thicker easily. But if you have an irregular structure like this, the particles are no longer moving in a very smooth and convenient way. So that's why alloys will become less malleable and ductile to make the application more sensible. It is more corrosion resistant, I have explained, less malleable and ductile, has a lower electrical and thermal conductivity, I have explained, has a lower melting point. So what can be the use of having a lower melting point? Can you think of it? I give you 10 seconds. 3, 2, 1. You know, for example, in extraction of aluminium oxide, we need to melt the metal oxide in order to make it molten for electrical conductivity, to make the electrolysis possible to occur. So if you have very high temperature, high melting point, then that means we need to waste a lot of energy to melt the metal oxide. So that's why we will add some impurities into it to make it lower melting point. Alright, so alloy is, I think, if alloy have a lower melting point, then that will be a similar case. If we want to melt the metal to make it to different shapes, then we need to use a high temperature to do so. So if the alloy have a lower melting point, then we can tailor make the shapes of the metal objects easier. Right? That will be the advantages of having a lower melting point. Okay, for more examples of alloys, you can refer to tables here and also on the logs. Of course, you are not required to memorize these. It is just some examples to illustrate that alloys are very useful in our daily life. Okay, you know, steel plus carbon, okay, not necessarily to be the metal mixture, can be used as the construction and tools. Brass, it can be made to be the musical instruments. That will make the more attractive color and also more corrosion resistance. The bronze, 青铜, it can be used to be more corrosion resistant. The aluminum, it can be used to make the bodywork of aircraft. Okay, so these are just examples. You do not need to remember all of these. Okay, if in case they want to examine you, I think they are trying to investigate whether you can apply the old knowledge to new things. So that means they will provide you some background information. Okay, good luck to your exam.